So now we are going to do this question and we are going to understand some important portfolio concepts with the help of this question. It's a very good question. It will cover the portfolio beta. It will cover systematic unsystematic risk. It will cover the Sharpe single index model, Markowitz model for finding portfolio variance, etc. It's a good question to understand all these concepts. So let us start. We are given data of three shares ABC and portfolio weight, their betas, expected return, and total variance. All right. We have standard deviation of market return 10%. Then we also have four variants of A with B, A with C, B with C. We are required to calculate portfolio beta first of all. Okay. Now we have portfolio of ABC and which A considers 20%, B considers 50%, and C considers 30% of the total weight. So first of all, let's move on to calculating portfolio beta. So portfolio beta, remember, is nothing but weighted average of the betas of individual securities in the portfolio. So let's see portfolio beta, or as you can write, beta of portfolio equals to nothing but weight of security A into beta of A plus weight of B plus beta of B plus weight of C into beta of C. So weight of A we have 0.20 into beta of A is 0.40 plus weight of B is 0.50 into beta of B is 0.50. Weight of C is 0.30 into its beta is 1.10. And if we calculate this, so let's see, all right, this comes to 0.66. Okay, the beta of portfolio is 0.66. So that's our first one. Second, we are required to calculate residual variance of each of the three shares. So see, we talk about variance of security. We can divide this into two parts. One is systematic, another is unsystematic. So unsystematic risk is basically risk which is attached to that particular stock. So it is only pertains to that specific stock, right? The problem with the company, the problem with its persons, right? It is not my market diversifier, market risk. Whereas systematic is basically macro risk, like market risk, let's say interest rate risk, which affects whole of the stocks in the market. So this risk is basically this is systematic unsystematic risk can be eliminated by way of diversification. If you diversify now, you can definitely get this to nearly zero. But the systematic risk continues to occur even if you have diversified. Okay, so the total variance can be divided into systematic and unsystematic. Residual variance, unsystematic, and unsresidual are same. So basically, we are referring it as residual variance only. Okay. So the now task becomes now we can find out the unsystematic or residual risk by total minus systematic. Alright, the task becomes to find out this systematic risk. Okay. So how do we find that? So systematic risk can be calculated as the beta of the security square into variance of market square. This is from Sharpe's single Sharpe single index model. Okay, that the variance of the stock can be calculated. Sorry, systematic risk can be calculated as beta square into market square. Okay, so let's figure here only systematic risk service. I'll just use the column. So, for example, if you consider A, so the beta of A is what? 0.4. 0.4 square into standard deviation of market square. So we will bring in variance. So it is nothing but standard deviation square. 0.4 square times we have what? 10 square. This was 10% square. So that will just be clear. This will be what? 10 square 100 upon 100 square. That is, that's 100 upon 10,000. That is 0.01. Okay. Into zero point 0.4 into zero point 0.4. That is 0.0016. This is actually 0.0016. Okay. To be clear. All right. Now we can describe this as like top to our conclusion, which is 0.0025. All right. And this is again, this will be 0.0121. You can just subtract to find out the residual values. So I'll just write residual value. First A, that will be 0.015 minus 0.0016. So 0.015 and 0.016, that comes to 0.0134. Then for B, 0.025 minus 0.0025. That will be 0.0225. And finally for C, we have 0.100 and 0.0121. And that will be 0.08. All right. So these are our residual variances for all the three stocks. Okay, so let's now move on to third part. I hope that's clear. I'm going to explain that how we are find out. Basically, we have total variance. We have figured out systematic risk with this. The balance will be the residual or unsystematic risk. Third, we need to find out portfolio variance using Sharpe single index model. So portfolio variance using Sharpe single index model. So it's basically if we consider individual securities variance using Sharpe single index model, it's nothing but the beta square into sigma m square plus error terms square into Z square. So let me just try to. So for it's for finding risk of security I, what we'll do is beta square into market square plus the error terms into which weight. Okay. For the finding of portfolio variance for a for finding a variance on portfolio, here we need the weighted average beta of portfolio, which we already found out in the first part. The rest parameters remain same. So we will just use this equation to figure that together. The beta of portfolio we already figured out as 0.66, and market square, so we have 10 again, so 100, that will be 100. Yeah, so error terms we have to open. So we have, remember, figured out here error terms. How we will use them. So these are the error terms. We just multiply by the rates of portfolio. Alright. So for example, for a point 20 point let me see, point 20 square, weight square into, this is actually weight square into the error terms. Okay. Sorry for that. Point 20 square into 0.0134 plus weight square into basically error terms square. Then we have 0.50 square into 0.0225. And finally, we have zero point 0.3 square times 0.0878. If we do this comes out to be 0.014072. Okay. Systematic variance comes out to be 0.004356. Let's add this up. That will come to 0.018420. This is the variance, portfolio variance in which optimal. So that makes sense. Finally, we need portfolio variance using Markowitz. Okay. This is interesting. Huh? What we'll do is we'll construct the variance covariance matrix. So we have on one side all the shares and the vertical side and horizontal side. We will basically construct a matrix. And the thing is, if you just add the all the variance covariance terms, you will get the variance of portfolio. That's right. And just do it right here. Yes. Okay, so let's see how we do. We'll just type the page here. Order. So 0.20, 0.50, 0.30. Also write the on the top. Okay. All right. Now we have activities A, B, C, A, B, C. Okay. Now, just a second. A, B. So this basically represents covariance between A and B. Like this represents covariance between A and B. Right? That makes sense. So this basically this will mean what? Correct. So this will covariance between this and this, B and C. Okay. So which is that's the meaning of it. I construct it. So remember covariance between A and A will be just variance of A. Okay. And variance of A is 0.015. Covariance of A and B is already given 0.030. Covariance of A and C 0.020. Then A and B and B and A, so 0.030. B and B is just a variance 0.025 from here. Then B and C 0.040 right here. Then AC, which is nothing but C and A 0.020. In DC, it's a CB, which is 0.040, and C is this variance of C. Okay, this is done. This is our variance covariance. Now, what they have to do is just basically multiply these rows and this number and just keep adding them. For example, 0.2 square multiplied by both times 0.015. No, do some 0.20 into 0.5 into this number. Just keep on adding this into this. I hope that now becomes repetitive, right? Yes, you have to do this into this 0.5 into 0.2 into 0.030. You just do this one. Add all the terms. Inside there. That's it. If you add this all, your answer is 0.05. That is the portfolio.